Welcome. So I am doing a talk entitled Expect the Unexpected with Shiny and HTML widgets. So as was said, for jumping with us, I think my official title is data scientist, but that really says not a lot about quite a lot. So I do training courses, introductory ones up to more advanced ones on Shiny and tiny models and stuff like that. And then I also do consultancy, so build Shiny apps, do machine learning, and then when they let me, I also do some project management every now and then.
So this talk is about a project we did with Utah Tech University. So Utah Tech's quite a forward-thinking university in that they have a center for data and research, and that center for data and research is really interested in using open source technologies, so stuff like R, Python, all of that stuff, to help evaluate and improve their university. But the really cool thing that we found out when we were talking with them is that everything that they also make open source as well. So all of the stuff that we've done and is in this project and is on this talk is all available on the Jumping Rivers GitHub and on their GitHub, and I'll point you towards that at the end. Now, they wanted to build two Shiny apps. So one to evaluate their student retention data and one to evaluate some data about student admissions as well. They're fairly good at Shiny themselves, so they didn't really actually need that much help with the Shiny apps. They could have done that themselves. The thing that they were really interested in was they needed two custom HTML widgets. So one for student retentions, which was a custom Sankey diagram, and then one for student admissions, which was a custom Sunburst diagram, and I'll show you what those are in a little second. Yeah, and again, all of this is open source, so at the end, I'll point you towards a couple links and you can have a look for it yourselves if you want to. So I'm now going to try over two screens and do a live demo. Let's see how that goes. So yeah, I'm going to show you what a Sankey and a Sunburst diagram are because they're pretty niche when it comes to diagrams. You don't see them in most applications. So we built two widgets. One of this is a Sankey diagram. Sankey diagram is basically just a flow diagram, special in that the widths of the paths between the nodes dictate some form of rate or total between those two nodes. Right? So in our Sankey diagram, you can see there's 3 columns. Each of those columns represents a column in the data, and each one of those nodes represents a category in that data set. So here it's on some penguins data. So one of the columns represents species, the next sex, and the next flipper length, right? And you can do a lot of cool things with this widget. So you can color nodes individually, you can highlight over, and it'll show the paths that go over that path and over those nodes. And you can do lots of stuff like custom pop-ups and whatnot as well. You can also drill down into nodes as well. So if you want to have a look at, let's say I'm really interested in Adelie penguins, I can click into that node, and now I get all the paths just relating to that. And then you can also, as well, in the R code, which I'll show you later on in the talk, you can also specify other columns that you want to drill down into through the original ones. So over on this right-hand side, this column represents the flipper length of penguins categorized into small, large, and medium, right? And what I've done in the code is I've said, right, if someone has a breakdown, someone wants to break down the flipper length, so someone wants to zoom in on like medium flipper length penguins, then what that's actually going to do is break those penguins down by their bill lengths as well. And you can specify this as many as you want, right? And there's a couple of other features as well that I don't really have time to go through. But yeah, we might see a couple of those later on. Now, the Sunburst diagram, from what I understand from the conversations that I had with the client, these are normally used for slightly different things than what the client wanted to use them for. So in effect, it's they're using it in kind of the same way that they're using it for the retention data. Normally you use these to evaluate like hierarchical data. What they're wanting to do is actually use this to just demo the flow of retention, student retention and student admission. So in effect, this is kind of showing exactly the same as what the Sankey was showing, but you're just getting an overall percentage of what's in the data, right? So this first inner ring is the same as what the Sankey was showing on the first column. It's just the species of penguin. right? And then the second ring is another column within the data, and the third, and so on. And you can follow these kind of paths as you go out the data. So I can see now that there is 8.4% of the data is large as Gentoo penguins that are female with a large flipper length. Right? And you can do a couple of other cool things. You can zoom in on specific segments if you want to. You can color specific segments and so on, all to the spec that the client wanted. Right? So that's what we built. So throughout the course of this talk, what I'm going to do is show you kind of the things that went into building that, some of the things that went right, and then some of the things that we didn't expect, how they went wrong, and kind of what we did to remedy those. So there was 3 components, right? There was the, first of all, these are kind of custom widgets with a custom spec. A couple of these things already existed, a couple of the bits of code we borrowed, but a lot of it was custom JavaScript, so we had to build that. One of the main things that the client said was all of their devs use R, and what they want to do is have other people in the end using these widgets using R, and so we had to take the JavaScript libraries and wrap them in an R package using the htmlwidgets framework. So that was step 2. And then step 3 was, now that they're HTML widgets, how can we make them usable and shiny and user-friendly and shiny, and then put them into an app for the client. So my challenge in this project was that I don't really know JavaScript, right? I could maybe do like 1 + 1 and assign a couple of variables. But I don't really know JavaScript. HTML widgets, I'm aware of the language it's built upon, R, right? I'd like to think I'm okay at R. Some people at Jumping Rivers might disagree. But I've never really made a HTML widget. Shiny, I think I'm okay at as well. But yeah, my big challenge is I don't really know 2 of the main 3 components of this project, right? So how did I do it? And the truth is I didn't do any of it, right? So I was the project manager. I made sure the cogs were turning, that the conversations with the client were on time and everything was moving correctly. But actually I had a team of developers around me, all obviously from Jumping Rivers. And so a lot of the things that I'm going to be talking about on this talk, I didn't actually do. Russ did it, Mandy did it, Keith and Tim as well. So it might be one of the first sessions, probably the first session of the day, where I'm going to have to hand over to the chair for answers later on for the technical questions. Cool, yeah, so I had way too much to talk about during this. When I was asking the team for things to talk about, there was a lot of features. First run through was probably about 40 to 50 minutes, so I've had to cut them down. A lot of unmentioned stuff. If you do want to have come and talk to us about the widgets or any of the apps or any of the process, feel free to come on up to us at the end, and I'll probably point you towards one of the 4 people working on it, and not me. So the first component, the JavaScript. What I'm going to do is take you through for each stage some of the components that we planned and scoped and went well, and some of the things that took us a little bit by surprise and how we remedied them. So for the JavaScript, what went well, that stage, what went well, right? In the Sankey diagram and the Sunburst diagram, you have to calculate some like rates and totals, right? So on the Sankey diagram, when someone inputs some data, you've got to calculate some rates, so the kind of widths of the paths. And then for the Sunburst diagram, you've also got to do some percentages, total percentages. And there's a bit more that goes on behind there as well. The first question we had was, right, where is that going to happen, right? So there's 3 options for that. Where are these calculations going to take place? So the first option is that we don't do any of it, and as long as we define the format, then the end R user, so the person who's using that Sankey function or using the Sunburst function, they can do that, right? We specify a format, they have to wrangle it into a specific format, and then that's it, that's job done, right? Option 2 is that we actually have to do some of the work. So the R user can pass in some kind of sensible data format, something like tidy data, or 1 row per observation. And then the HTML widget developer will receive that from the user, they'll wrangle it into the specific format and pass it through to the client side, to the JavaScript side. Option 3 is that the JavaScript developer does everything. So the R user passes in some kind of format of data, probably tidy. the HTML widget developer will then take that and pass it through to the JavaScript developer, and they will do all of the wrangling and then show all of the pop-ups and all of that stuff. So we went with option 3. So Tim had to do pretty much everything regarding this. We found that when we were kind of evaluating all of these options, option 3 had 2 main pros. One of them, as an R user, I found particularly appetizing was that I don't have to, as an R user, worry about wrangling that data into a specific format. If we're aiming this function to be used by lots of different universities around, some people might not have the best R experience, might not be the best at wrangling data into specific formats or coming up with means and attributes and stuff like that. Then if they can just pass through tidy data into this function, they don't have to worry about everything. We're taking care of that for you. Now, point 2 is that, well, because everything's on the client side of things, all those actions on the widgets are instantaneous. So all of the pop-ups, all of the highlighting, everything that, all of the calculations that are done are instantaneous because it's not going back to the server and doing any exchange of messages and saying, right, I need to calculate a mean, going to the server, calculating that mean, and the server's passing it back through. So all of that stuff's instantaneous. So what cropped up that we didn't expect? Right. So when the client defined their spec, they said, right, on the Sankey diagram, we want there to be pop-ups that display some sort of information about that node or that path. Right. Now, in the spec, we really clearly defined what the content of the pop-up was going to be, but hadn't very clearly defined what the styling of the pop-up and specifically the background. And it was surprising to me through conversations with the JavaScript developer as to actually how many options for a background of a pop-up you can have, right? So the first option is that you've got this transparent background, right? What I did like about the transparent background is that you can still see the shape of the paths behind, all of the information that's there, so all the nodes and the shapes, but because of labels and whatnot, you can't really read some of the text that clear, so targets overlapping true and links overlapping graduated that. Right? So the next option is just something completely opaque, and a lot of the HTML widgets packages just do this anyway. So in Leaflet, when you get a pop-up, unless you suggest some other styling for it, it's just opaque naturally. Right? Now, whilst this is good and you can read the text, what I didn't like about this is that you're missing out on all of that information that's behind the pop-up. So we can't see those paths, which is quite a crucial thing for the Sankey diagram, and I can't tell that there's some labels behind them. So we found a really nice fix, which is only 1 line of CSS code, and that is you take the background, you keep it as transparent, but you blur it instead, and you can specify the amount of blurring that you want as well. So now I can see the paths, I can see that there's nodes behind there, I can see that there's labels that I can't necessarily see at the moment, but it's just blurred out, so it's clearer. And it's literally just 1 line of CSS code, right? So it's this backdrop filter, and you set it to the blur function, and the pixels dictate the amount of blurring, right? So really easy win on that case. But it's something that took us a little bit longer than we thought it would because we didn't spec it out at the start. Right, so on the Sunburst diagram, there is a breadcrumb path at the top, right? So the breadcrumb path is that thing at the top with the arrows, and that helps the user see exactly which path they're hovering over and what categories and colors they belong to. Right. Now, we kind of had a similar problem here, but we'd actually thought quite in depth about the styling, right? We'd said it's going to be arrows. We said it's going to match the colors of the segments that you're hovering over. The thing we didn't think about was the text, right? So at the moment, that was the first iteration. That's just plain black text on this breadcrumb at the top. And the reason that's bad is because, well, the Sunburst, the way that it's designed, it's going from dark colors to light, and a user could change that if they want to. But the black text on the left is quite difficult to read because it's a dark background. The black text on the right is easy to read because it's a light background. If you change that to a lighter color, you've got the opposite problem, right? It's easy to read on the left, but harder to read on the right. So what we did was we put an outline around the text, and to me, the thing that isn't interesting is actually, it's not interesting the actual outline around the text. To me, what I found interesting was there's no method across all browsers to just add an outline to text. It doesn't exist, right? And so what you've got to do is add a shadow to the text, but in some really weird way, right? And now that we've got this outline, we can see everything. So again, it's something that cropped up that I didn't think I'd have to talk about in front of a stage of people, is we've got this text shadow and it's now, we can see things. And that's also meant to be one line of code. I just had to split it over a couple to make it fit. All right, so stage 2 and 3, these two stages were quite intertwined, the HTML widgets and the Shiny one, so I've combined them into one group there. So HTML widgets, there's been a couple talks on this today, so I don't really have to define this, but it's a framework for combining R bindings to JavaScript libraries, right? So you can take a JavaScript library, wrap it in an R function, and then people in the R world can use it. And there's loads of packages that are already built using these. A lot of these, many in the room will already have used. So Plotly for interactive graphs, Leaflet for interactive maps, DT for interactive tables, and loads and loads more. So our HTML widgets, the R code looks a little bit like this. So the package is, for the Sankey diagram, is called utviz Sankey. The client wanted it to be named after the university, obviously. The main function in it is just called Sankey, right? It does take in more arguments than this, but for time's sake, I'm only going through a couple of them. So there's a data argument for the data set, right? You can specify exactly what columns you want the nodes to represent, the color of the nodes, and then you can override certain nodes with different colors and groups and whatnot. And there's a couple of other arguments in there as well. Now, Sunburst is pretty much the same. So when we were designing these, we decided it was a good idea to have both of these packages work pretty similarly on the front end of things in R. So package is called utviz Sunburst, function is called Sunburst, and it basically works the same way, right? One argument for a data set, one argument for the columns that the rings represent, and then one argument for overriding colors. And again, there's a couple of other arguments that we don't have time to go through. So what about this particular section of the project went well? What did we plan and how did that go well? So one of the needs of the client in the kind of vendor that they sent across was, on the Sankey diagram, we want someone to be able to see the data represented by one of those nodes, right? So they've got a load of these nodes in the Sankey diagram here, and if they do maybe like an alt click or a shift click or something like that on one of these nodes, then you're going to get a pop-up with that subset of the data on there in some form of table or like reactable or DT table or something like that. So as far as we were concerned, there was two options for this. One was we could make Tim do everything again, right? So Tim would write the custom event handler. Tim would then write all of the UI code to make everything pop up and look nice. The other option was a bit of a mix of everyone and a mix of the end user as well, so something that we don't have to do. So effectively, what option 2 would involve was we'd still have to write a JavaScript event handler, which is just basically a function that runs every single time an event happens, right? So that would be alt-click on a node, for instance. And then the HTML widgets developer would, as part of the R package, create a custom input handler for Shiny. And basically, what that custom input handler will do is take the data from the client side, process it into a sensible R format. So something like, instead of it being in a horrible JSON list, it would be in a nice tidy tibble or whatever. And then it would send that data to an input in Shiny, right? And then the R user bit at the end is, well, now that we've done that and provided the user with a way of collecting that data via an input in Shiny, we don't have to do anything. We don't have to make the pop-up. They can just do whatever they want with it, right? So maybe they don't want to be locked in with the pop-up. They might want to display the data permanently by the side. They might want to omit some certain columns when they're displaying it, but now they can choose to do whatever they want with it. So it removes some of our work and then makes this tool a bit more flexible. Right. So this is what this looks like. This is condensed down quite a bit, so there's a couple things that aren't in here. But effectively, what you have to do is write a JavaScript function in R, right? and it has to be presented as a character string. And effectively what we're saying here is there's a little JavaScript function here. Where are we? There we go. Right? And that says I want to set a certain Shiny input value equal to something. Right? And effectively all you're saying is set the input value named this, so it's a Shiny input var, and set it equal to the output of this function. And this function is effectively the input handler that was written that converts the data from some horrible format to a sensible format. Okay. The way that we've written the package is that you then take this, pass it through to the Sankey function, and then in Shiny, you can just magically do some stuff, right? So if you have an observe event, and that depends on the input variable that you've just created, that input value will take the value of the data that's being passed through from the client side when someone clicks on a node, and you can do whatever you want with that, right? And there's things we could improve about that workflow that we've communicated with the client already, but it works, and it's, yeah, they're happy with it. So what about this stage was surprising to us? Well, when we were testing the HTML widget for the first time, all of the documentation was in a vignette. That was great, it was working, and all of the features were working. When we went to move it to a Shiny application, effectively what happened was the widget was duplicating on the page. Basically, every single time you went to change a data source in the Shiny app, it would just add another widget to the bottom of the widget, right? And this is why this was happening. So inside the R package, where the widget lives, right, there is a JavaScript function that is ran whenever you call that Sankey function. Inside that JavaScript function, there is a return statement, and basically this function at the end returns another function, right? So this function is called render value, and this render value function is the thing that is called every single time the widget updates on the Shiny app, right? Now, at first pass, inside this render value function, we put some code to initialize the Sankey visualization, right? We then put some code to add data to it and render it, right? And then the last piece of code, which is the crucial one, is we put some code to append that to the page, right? Now, yeah, this doesn't work in Shiny, right? So in HTML, in Shiny, a widget's contained within an output element, right? Which will react whenever any values that depend upon it change, right? So for instance, a drop-down menu or a slider or something like that. And in our app, the user is able to change the data source that this depends on. So basically filter the data that it depends on, right? And so every time that data source is changed, this render value function that contains these lines of code to initialize and render it and append it will run every single time. So what was happening was you would start off with some widget on the page like this. Someone would change one of the drop-downs, and then we'd get to that, right? Every single time someone changes one of the drop-downs, it does it again, and it keeps on adding widgets to the bottom of the page, right? And so you get the newly updated widget there, but the old one still lives there. Now, it was a fairly easy fix. I say fairly easy, I didn't fix it, right? And it was only fairly easy once we'd figured out what was going on. So it turns out, because this render value function is called every single time the function runs, every single time someone changes the data source, all you have to do is those two lines of code, right? The append child one that puts the visualization on the page, and the one that initializes the Sankey visualization, right? You just have to take those and keep them in the function, but put them outside of the return function. So when the Sankey function is originally called, it runs those two lines of code, adds it to the page, and then we update the code. So each time it's called, we only add or update the data for it. We don't append it again. Cool, so went through that a bit quick actually. So before I go, so all of this is open source, as I said at the start. So you can find it on our GitHub page. The Utah team have taken it and they are just making some styling changes and some changes to a couple of drop downs and whatnot. So if you want the most up-to-date version, you can head to their GitHub, which is just DSU effectiveness. And then finally, yeah, again, I didn't do any of this, and if it wasn't for the hard work of Keith, Mandy, Russ, and Tim, none of this would have been possible. So thanks to them as well. Yeah, thanks very much.